So you essentially have an adult molar. We have, just near us, a company that takes out wisdom teeth, a doctor. And so he gives us a bunch of teeth. So we've got jars of teeth. And so we took one and sectioned it into 4 sections just to ensure density, ensure that it was the same, instead of taking 4 different teeth. So we sectioned that. And then just over here you see, this is the zirconia. So we prepared these samples here at the bottom. These are the teeth right here. And then these samples here at the bottom are the 4 different brands of zirconia. And so we've fixed them in their jigs. And then, has anybody seen one of these machines? A mechatronics machine? It's a chewing simulator. So not something most ordinary people ever see or use. But this is in our office, and so we got this machine from Germany, and you do the simulation, and then you send the results to them actually, and they do all the measurements and give you all the data and the results. And so we have that data for the effects of this meeting. I'm just showing visually what the difference is. And so what we did is we did a 1,250,000 cycles of simulated chewing in this simulator. And in doing that, 1 simulated chew per second results in 2 weeks of mastication. So it equals essentially 5 years of duration, right? So 1.25 million chews. And so over the 5 years, you can see, so here's the visual results. So Beyond Plus Multi, that's essentially your wear. And then a material imported from Asia, also a multi-layer zirconia in A2. And then another material that's made in the US, multi-layer zirconia A2. And then another competitor from France, also multi-layer zirconia A2. And so as we look a little closer at the results, so this first column, just kind of an angled view, and then the top view. This is really the best view to see the wear that we've experienced. And you'll notice that the wear is really directly proportionate to the particle size, right, or the grain size of the zirconia. And so this is one of the aspects that we'd measured. And as zirconia is getting more and more translucent, what's happening to the particle sizes? Can anybody guess? So they're getting bigger. Yeah, and that's part of the problem. So you're adding yttria, and it's creating larger grain sizes. And so that's why this study is incredibly important, just from the aspect of that's where the industry is going. It's getting bigger and bigger, the actual grain sizes. And so you'll see the uniform distribution. You'll see the smaller grain size. That's why it wore less, right? It's like sandpaper. I mean, if that's what we're comparing it to, a higher grit versus a lower grit, versus this one where it wore the most, these two, where you have these large particle sizes. What's really pretty interesting, if you compare this brand, this competitor, also made in the USA, and then this one, there's smaller grain sizes than these. These are larger, but this is actually a more translucent zirconia. And so that's, again, where I'm talking about this gap of you can make these small particle sizes, but by going through a colloidal process, by making a colloidal process, you can shrink that gap of strength and translucency and get them closer.